So, this is
a picture
of the Big Bang. So,
So
that's probably how it looked like.
maybe a little bit, yeah. Okay, our next stage is talking about what created the stuff that our solar system is made out of. Okay, bye.
Bye.
Now, now we are gonna start talking about stars. This is a red giant star. This star is very big. These types of stars, well, these are the older types of stars. They're the stage after the yellow star or the golden star or whatever.
Yeah.
Okay, so there are also not red giant stars, but there are bigger types of stars, and those live shorter lifespans. Right?
Because they burn more.
Oh yeah, because they burn faster. And shorter ones, tinier ones,
They burn longer.
yes.
So they live longer.
Okay, now we're going to go through the process of a big star. Go.
Okay. So, of course, large stars start out with large nebulas. So this here is like a nebula.
And it has gas, and a nebula is a ball of gas and dust. So this is a
Well,
ball.
it's more like a cloud, though.
Yeah. Okay, this is a big supergiant because after
See, the blue part is actually the supergiant.
yeah, so it takes all the gas and dust together and makes a big blue supergiant. Oops. Wait, no, you missed out.
What?
Oh wait, ooh, I got a really good idea. So we draw a blue supergiant.
Actually, very, very sorry about that.
That you just heard all that we were talking about.
I'm very, very sorry about that.
No, stop talking. Okay. So, since the blue supergiant is very, very big, it burns very, very quickly. It only has fuel for about for only a couple of millions of years.
Which is very quickly.
Yeah, for stars. Because other stars burn like very slowly. And like billions of years. So, yeah. And, yeah. All the gravity of the blue supergiant pulls its fuel back onto it. Luckily, happily, ever after. But just wait, that's not very. Okay. So now the blue supergiant, with all the matter attached to it, explodes. It's a very big explosion. And it's called the Type 2 supernova. And that's very scary. So what's left after the big explosion of the Type 1 supergiant, Type 2 supergiant, is a black hole. A black hole can suck you up and y'all be bye-bye. I know that's sad, but you probably won't be in space anytime soon, so you won't.
So, yeah.
That won't happen
Just
to you.
don't worry about that part.
Yeah.
When the star is dead, it goes to here, so dead, that's supposed to be a dead star. And that equals a planet, because when the star dies, eventually it turns into a planet.
No. Because the stuff from the leftover star, like the elements, they form planets.
So it still turns into a planet, though, because all the leftover stuff. Yeah. Now let's talk about
how the Earth formed.
Okay, sorry about that.
She just like.
Sorry about that again.
Formed.
Yay. Now,
we're gonna talk about plants. So the planet starts
planets, not plants. You said plants.
Oh, sorry. The planet, our Earth, starts as begins as dust and gas. This is called a nebula.
That's
Just
a
like our
nebula
sun,
here.
right here.
Now, so this is like here, so it's like here is the sun forming. Whoops. Okay, so here is the sun forming.
In the middle.
Yes, in the middle, because this is the middle. And when gravity causes matter.
No, the sun's gravity.
Yeah.
It causes the matter
To move in like
around and round and round and
circles,
round and
pretty
circles.
much. So yeah.
Okay, so now the dust and the gas and everything starts pushing together, colliding basically. It's sticking together, stick, and that creates planetesimals right here. And this is the gas and dust and everything right here. Okay.
Here, these things, what I'm pointing to, they're planetesimals, so the gravity pulls them together, and when the gravity pulls the planetesimals together, it like turns into planets.
And they're groups of planetesimals, not just planetesimal, because they start colliding themselves, and then that makes groups of planetesimals. And then those get pulled by gravity, and that creates
into a planet.
Yeah. So now, mind the singing in the background, okay, guys?
Yes, we're very sorry about that, but the other group is doing that, so.
So now, the planets that aren't that big yet collect all their matter in the orbits that they're in, and that makes their bigger planet. And that still don't care about the singing in the background. So, yeah. So and that makes its real planet.
This is the next stage, which is how the sun formed. So, yeah, I was gonna do it.
Fancy.
That's like, yeah. So the next stage is how the sun formed.
Our sun starts as just gas and dust spread all over the place.
So gravity pulls it all together, and well, it forms a nebula like everything else.
Okay, so now, as gravity keeps pulling the nebula right here together, the hydrogen atoms that make up this they make up this whole entire gas and dust and everything like that, get squeezed together, squeeze. So one hydrogen atom, another hydrogen atom, squeeze together, squeeze, and those make helium atoms. A helium atom, and this, yeah.
This is called fusion, and in that process of fusion, radiation gets released. So radiation is what makes our sun glow the yellowish color that it is now. And well, it warms up everything like the Earth.
Fusion process that we are talking about, this actually happens 1 billion times a second. Yes, I know, that's a lot. But it needs to happen, and that's why our sun is the sun. It's because if it only had 1 time a second, it would just be bye-bye. So, yeah. Okay, so someday, about in 1 trillion years, our sun will run out of hydrogen. So you have to say bye-bye to hydrogen. But luckily that's only in 1 trillion years, so don't worry about it. Then the sun will pull together helium atoms into sets of 3 to make bigger atoms. These atoms are 6 times bigger, but they're still very, very small. These atoms are called carbon atoms. Carbon atoms.
So,
We are.
wait, okay, sorry about that. This reaction of 3 helium atoms turning to carbons, it's like super hot, so it makes a red giant. A red giant is about the same size as our sun, but the red giant was much hotter. So yeah, this is
The red giant.
the red giant. Well, yeah.
So the red giant eventually runs out of fuel, and can I wait a second? This is where new planets can come from when it runs out of fuel to create planetary nebulas. This is where new planets can come from, like we talked about before. It's not working. Is not making heat because it is not radiation. There's no radiation from the nuclear reactions. So since it is not, there's no it's not radiating, it will not glow as much. Gravity is still pulling it together. So this is called a white dwarf. Then what's all is left over of our sun, which is the white dwarf, eventually dies or burns out, and what is left is what people call a black dwarf. A black dwarf is made out of all the leftover carbon atoms. The black dwarf is the last step. Okay.
Made with Doodlecast Pro.